Hello, in this video we are going to have a look at factorization by grouping. Now we've looked at this conceptually in class, so these are just 4 examples which will help illustrate this idea of factorizing by grouping. And remember, factorizing means taking an expression like this and turning it into a product, which means 2 or more simpler expressions multiplied together. So let's have a crack at it. If I put brackets around these 2 terms and these 2 terms, then I can take out a common factor, sort of, in that the first 2 terms have a common factor of x squared. So remember, we look at the coefficients and take out the highest common factor, and then we look at each of the variables and take out the lowest power. The lowest power between x cubed and x squared is x squared. And what does that leave me with? It leaves me with x squared times x gives me x cubed, and x squared times 1 will give me x squared. So I'll just leave with an x plus 1 there. And note, it's the same as that. So there's no need to take any more factors out of it. So that's just the second factor there. But if you want to, you could put plus 1 there in front of it to remind you that when you've got a bracket with no value outside of it, you can artificially put 1 there, because 1 times anything is just itself. And what that allows us to do then is to take out a common factor of x plus 1. Now again, you can do this bit in your head, or you can do it physically. I'll do it physically for each of these problems here, just to remind you. So we can say let a equal x plus 1. Then we have x squared times a plus 1 times a. So it's a common factor of a outside of x squared plus 1. And then we can substitute back in. Instead of a, we put x plus 1. I would be very comfortable with you seeing, even if it's not straight away, but by the time you've finished a whole set of problems, if you see you've got a common factor of x plus 1, then that becomes a common factor here. And then when you look at what's left over, the x squared plus 1, that becomes the other factor. Done, done, done. Let's have a look at example 2. Same dealio. I'm going to put brackets around here and brackets around here. And then I'm going to take out common factors. So we've got, actually, you know what? I'll just color code them again because I think it's kind of useful. So we've got ab squared and 2a squared b. So looking at the coefficients first, there's a no coefficient here, which means it's a coefficient of 1. And there's a coefficient of 2 here. So there's no common factor there in the coefficients except for 1. We've got a and a squared. So that's a common factor of a. And we've got b squared and b. So that's a common factor of b. Open the brackets. And that leaves me with what? ab times b gives me ab squared. ab times 2a will give me 2a squared b. So there's the first bit. And then we'll take the second bit, 3a plus 6b. Look at the coefficients first of all, 3 and 6, highest common factor of 3. Look at a and b, no highest common factor there at all. So I've got 3 outside of a plus 2b, like so. Now, I'll tell you now, I made a mistake. I completely mucked up my a's and b's there in my second one. If I got this far, a plus 2b is not the same as b plus 2a. There's no common grouping factor here, and so I'd have to stop. That's my fault. I'm sort of not the sort of person who would sort of just try and fake my way through that. I just made a mistake. So let me go back here a bit and magic away my mistake. Bum, 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 bum. And what do we want? Let's make that 3b plus 6a. And then the common factor of 3 means I'm left with b plus 2a there. And now it'll work. Yeah, sorry about that. So again, we can do the same thing if you want to. You can go let a equal b plus 2a. Then we would have ab multiplied by a. Big A is different from little a, by the way, in mathematics. Plus 3 big A, common factor of a, leave me with ab plus 3, and then substitute back in again. So we've got b plus 2a, and then we've got ab plus 3, all factorized. Okay, so we've gone from an expression with squares in it and stuff to expressions multiplied together that don't. So you'd say they're simpler expressions. Example 3. This has got a little bit of a trick to it, this one, which is why I've done it. So let me just take it a little bit slowly. I'll just bracket that bit up first, and we'll work on that first. Trust me, there's a reason for it. So x cubed and x squared has a common factor of x squared there. So I take x squared outside the bracket. X squared times x equals x cubed, and x squared times 1 equals x squared. So that's that bit done. Now you need to be careful with this next bit, and I'm almost reluctant to put my red brackets where I normally would do. So I'm just going to use dots because I can't really put in brackets like this, but I'll just start with some brackety there to say these are the two terms I'm going to bracket together. And I've got to be careful because if I put brackets around this bit, this minus affects what's going on the inside here. So you've got to be careful with that. So let's see what happens when I take this through. I'm going to put a minus and a bracket in here, but now I'm going to say, what does that really mean? Well, again, I'm going to do dots again, but it doesn't have to be. It's like I've got a minus 1 outside the bracket. Minus 1 times what equals minus x? And the answer is just straightforward x. And here's the trick. Minus 1 times what will give me minus 1? And the answer is not minus 1, but plus 1. So when I've got negatives involved here, just be mindful that when you start putting brackets in, it does change the signs of things inside the bracket. The minus x became positive x, the minus 1 became positive 1. And we've now got a common factor of x plus 1 as well. So be careful of that. If that was minus x plus 1 here, then it wouldn't work out. All right, I hope that makes sense. Use your usual thing if you want to. You don't have to do this. You can go straight to the final line if you want to. Let a equal x plus 1. Then what do I have? I've got x squared a minus 1 times a. So that's a outside of x squared minus 1, like so, which is equal to x plus 1, x squared minus 1. And that's all I'd expect you to do from this point on, or from this point, I suppose. But some of you might be able to see that there's further factorization that could be done. Pause the video and have a look at it and see whether you can figure out what you need to do. Okay, I trust that you did at least think about it, even if you didn't do it. But yeah, it's this second factor here, the x squared minus 1, is in fact a difference of two squares. So I can continue to factorize by saying that x squared minus 1 is x minus 1 times x plus 1. So there you go. That's its fully factorized form. And if you want to be really, 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 really schmick, you can see that this factor is repeated here. We've got an x plus 1 multiplied by an x plus 1. And you probably should know what a number multiplied by itself is. It's a square. So you could write it as x minus 1 multiplied by x plus 1 all squared, or x plus 1 squared times x minus 1, either way. So that's the schmicko way of writing it. But yeah, I wouldn't have expected you to have got that far. Example 4, I've deliberately put down to just to remind you of a very simple premise. Now, let's start off with this problem. Y cubed plus 2 plus y squared plus 2y. So we can start off in our usual way and put brackets around here and put brackets around here. But what we don't have is a common factor in these two, although we do have a common factor in here of y. But it's not particularly useful, right? So what I wanted to remind you is that when you've got a whole bunch of things just added together, then that's the same as if you add them in a different order. You know, like 10 plus 3 plus 5 is the same as 5 plus 10 plus 3 is the same as 3 plus 10 plus 5, etc. Rearranging it doesn't change the value. In this case, I'm just going to reorder them slightly so that I've got the y cubed, then the y squared, then the 2, then the 2y. So I've simply swapped the location of the y squared and hence swap the location of the 2. Okay, so we've just switched those over, but nevertheless, it hasn't changed the overall value of this expression. But the benefit is I can now take these two and I can take these two, and I will, you'll see it, I will have a common factor. I think I will anyway. Let's have a look. Y cubed and y squared has a common factor of y squared, which leaves me with y plus 1. Again, if I'm going too fast, just don't hesitate to pause the video and think about it for a bit. And then we've got a common factor of 2 here, and that leaves me with 1 plus y. Now, I just wanted to point out a little thought bubble, random thought bubble here, that don't forget that because order doesn't matter, y plus 1 is the same as 1 plus y. So even though they look different, they are the same factor. Okay, y plus 1 is the same as 1 plus y. So we can do our usual if you want to, you don't have to. Let a equal y plus 1. Then we have y squared a plus 2a. Take out the common factor of a to get y squared plus 2 left over. And then I can replace the a with the y plus 1. So I have y plus 1, y squared plus 2. And I'm pretty much done. I mean, if I have a look at this, I've got y squared plus 2. I probably need to just check. It's not a difference of 2 squares because it's a plus instead of a takeaway. So that's not a square number anyway. So I'm pretty sure that there's no other way of factorising y squared plus 2. And so my job is done. Okay, so there's 4 examples on grouping. So what you need to do now is take the worksheet that should have been handed out in class, and if you didn't get the worksheet, it will be on Google Classroom attached to the same post as this video. And I want you to do all the working out for the grouping in your workbook, and you can obviously do the answers on the worksheet itself if you have a physical copy. And let's see if you can solve the puzzle. That's it for me.